So following on from the previous video, in all the videos so far, I've shown you how to manipulate sine of x or cosine of x, where the amplitude stays the same. So now in this video, I will show you how you can increase the amplitude as time goes on. So if you have a graph of time here, you see this here, the amplitude increases here or decreases here. So to create this effect, you would start with your sine of x. So this is a graph of sine of x. Remember, our sine of x will look like this. The period being 360. But just to illustrate this, I've manipulated it so that the period is 4. So it fits neatly in this on this screen here. So well, you can do that yourself. So if you think about it, sine of x, y equals sine of x will give you a period of 360. Now to create the graph where the period is 4, you start out with this thing here, and then you look at something simple like y equals sine 3x. Well, sine 3x, it will give you a period of 1, 2, 3. You see, this here is 360. So from here to here, it's 120. You see, with sine 3x, it will give you a period of 120. So now I want a period where it's 4. So if you so this is 1 here, 2 here, 3 here, 4 here. So if you want a period of 4, you would start out by doing something like this. Hang on. Well, if you would start out by looking at this. Sine of x gave me a period of 360. Sine of 3x gave me a period of 120. Now I somehow want something. I somehow want a here where it will give me a period of 4. Well, hang on. 360 divided by 1. 360 looking at this here, divided. I don't know how. Well, you just got to develop your own way of getting to this a here. Somehow solve this a. Well, 360. If I have a 3 here, I know. Well, normally it's 360. I'm going to have three periods within this thing here. So if I divide it by 3, it will give me 120. Now I now want a period of 4, so I've got 360. I need to split it into whatever. Well, let's just call it a, where it will give me a period of 4. So now it's just a matter of solving for a. So times both sides by a, and then divide both sides. That will give you 360 equals 4a, and then divide both sides by 4. So it will be 360 over 4. That will give you a. Okay, that will give you a here. So you put this into the a here. So really this graph here is really y equals sine 360 over 4, and then you have your x here. So this graph here, for me to create a period of 4 here, I would I plotted y equals sine 360 over 4, and then stick an x here. Okay, so this to create a period of 4 here, you would get a graph plotter and do this here. Okay, so start out with this graph here. Okay, and we are going to combine. Now look at the graph of y equals x. Y equals x is like this: 1 here, 1 1, 2 2, 3 3, and so on here. So y equals x will look like this. Hang on. So negative 1, negative 2, and so on here. This is a graph of y equals x. Now to create this effect here, to create this effect here, where it gets bigger and bigger, you combine your y. Well, you see what I mean later. Now, looking at this point here, looking at the sine graph. So this is your sine graph here. Looking at the sine graph, when x equals 1 here, well, to create the effect, you would draw a graph like this: y equals x sine sine 360 sine 360 over 4x. Okay, so you so if you were to draw this here, it would look like this. Hang on, it would look like this here. And if you look at this here, when looking at the sine of x here, when it's 3, this is negative 1. So negative 1. So this is like one part multiplying another part here. So when x is 1 here, sine of x is 1. So this whole thing here is 1. This whole thing here is 1. And then later on, looking at the y equals x, this is also 1. So 1 times 1 is 1. Now if you look at 2 here, sine so we, to create the effect, we in effect have to do this: sine y equals x sine 360 over 4x here. Now look, this bit here is our red line here. Now when it's at, well just look at the 5 here now. Okay, well when x equals 5 here, when you put 5 into this thing here, this whole box here gives you 1. Okay, but then looking at the y equals x graph here, just this block here is 5. So 5 times 1 is 5. So this point here will move up to here. It will move up to here. So when one and then well, when it's 1 here, it's here. When it's 5, it gets moved up to here. Now this here 9. Okay, if you look at 9, hang on. If you look at 9 here, so we had y equals x sine 360 over 4x here. Now this whole thing here, when you put 9 into this x here, this whole thing here is just 1. Now looking at this here, looking at the y equals x here, when this is 9 here, this block here is 9. This block here is just 1. So 9 times 1 is 9. So this the amplitude here now moves up to, well, 8 is here. So we've got to move it up to somewhere here. So this point here moves up to here. This point here, remember, is 5. So it gets multiplied by 5. So it gets moved to here. 1 is here. Now looking at when x equals 3, when x equals 3, this whole block here is just, well, this whole block here is always in the range of negative 1 and positive 1. So when it's at 3 here, this whole block here is just negative 1. It's just negative 1. But this block here is 3, because you're looking at the y equals x here. This whole block here is positive 3. So now because we are looking at the graph of y equals this block times this block here, we have to get 3 times negative 1. Remember, negative 1 is this. Well, when it's at 3 here, this whole block here is negative 1. Look, negative 1. Okay, this point here is negative 1. So this block here, this whole block here is negative 1 times 3. So that would, well, 3 times negative 1, that will move it to here. Okay, and then looking at 7 here, 7 here will give you, well, the sine part will give you negative 1. Okay, and then the y equals x part will give you 7. So really 7 times negative 1. So that will take you to here. So my point is, so this point here is negative 1 times 3. So get moved to here. This bit here, it was 1, and then you times by 5. So it will be here. Okay, and then this bit here, the sine part will be 1, but then this part here will be 9. So it will get multiplied. It will move all the way up to 9 here. And then if you look at this here, the sine part will be 0, but then the x part will be 6. So 6 times 0 will still stay at 0. So in effect, it will give you something like this. 4 will be at 0, 6 will be at 0 here. So and this thing here will go all the way up to 9 here, and then it will come back down here. 10 is 0 here, so it's going to go back down to 0. So you can see the amplitude is increasing. Okay, so start out with your sine of well, you could just say sine of x here. Start out with sine of x. Okay, here if you were to do this here, your period would be 360, and then you multiply by x here. So you are really combining a graph of y equals x and a graph of sine here. Okay, at this point here is 1, but then this part here will take it up to here. Okay, and then this part here will take it up to here. Well, this part here is negative, so it would take you well, it would be like this. It would take you to here, and this part here is negative. It would take you to here, and so on. So to create this effect here, y. So if you look at y equals x, it would be here 1, 2, 2 here, 3, 3, 4, 4, 5, 5, and so on here. So it's really, you can see the amplitude is increasing. So to create this graph here, you would plot this y equals x sine 360 over 4x here. Okay, or if you don't care about the period, then you can just simply do this: y equals x sine of x here. So this here will give you a graph where the amplitude increases. Okay, and something else to note is that well, you see, when it's 1, it's up here, it's dead on 1, but the highest point is slightly to the right. It's not. If you look at this here, well, if you look at 3, the point 3 here, it will definitely take you to 3, but the lowest point is slightly to the right. This part is not important, but just notice that the highest point here is not dead on 1 like you would expect. If you look at sine of x here, this is 1 here. Well, it won't be. When it's 1 here, it's dead on 1, but the highest point is just to the right of 1. There's a reason for that, which you will understand when you're older. Okay, but for the time being, it's good enough for us to create a graph where the amplitude increases. Okay.